Okay, good afternoon class. So today we're looking at number patterns. So we spoke about quadratic number patterns, we spoke about linear patterns, not so? Or arithmetic patterns. So we come to a point where you should notice in exercise 3.2, which was your homework of yesterday, in each case the second difference is constant. The second difference was the same. You all agree with that, no? This occurs when the sequence is a quadratic sequence. Okay, so let's just change the reference here. We are doing examples for exercise 3.3 on page 73, and I'm reading from page . So the exercise on 75. Okay, thank you. Okay. So this occurs when the sequence is a quadratic sequence of the form Tn is equal to an squared plus bn plus c. The first difference between the terms of a quadratic sequence are not constant. The second difference are constant. Okay. In general, if you are given Tn is equal to an squared plus bn plus c, you'll notice that when you substitute 1 you see n, okay, it's going to be a plus b plus c, not so? So term 1 is a plus b plus c. For term 2, it will be n is now 2. So a 2 squared, which is 4a, b times 2 is 2b plus c. Term 3 is going to be 9 plus 3b plus c. Can you see that, people? So if we write that as a sequence, remember we will have term 1, term 2, term 3, not so? So there's term 1, term 2, term 3, term 4, term 5. They went all the way to term 5. And they worked out this difference here. So you say 4a plus 2a, 4a plus 2b plus c, minus term 1, which is going to be a plus b plus c. Not so? So 4a minus a is 3a, 2b minus b is plus b, and the c is cancelled. Yes, now we want you multiply the negative. Can you see that, people? So importantly on this point, we have 3a plus b. If we subtract those two, you're going to get 5a plus b. Those two, you're going to get 7a plus b. Those two, you're going to get 9a plus b. Now what happens if you say 5a plus b minus 5a plus b minus 3a plus b? There's going to be 5a plus b minus 3a minus b, which is 2a, and the b's cancel. So what do you notice? Your second common difference will always be equal to 2a. Can you see that, people? So with that in mind, you see this here? This is now going to become of utmost importance to us. On the first term's place, what do I have? A plus b plus c. What do I have on the first difference? In the first term of the first difference, 3a plus b. What is your common difference? Your second common difference? Always 2a. So this here is going to become of utmost importance to us. Right? You guys understand? So let's look at that application thereof. The second common difference we have told here. Just take this out. So here you should notice that the second common difference is always 2a in a quadratic sequence. Therefore 2a is your second difference. And your a of the sequence is going to be your second difference over 2. So it will always be your second difference over 2. But you'll see now we apply that. There are many methods to determine the general term of a quadratic sequence. Only one method has been illustrated in this chapter. People, there's more than one way of doing this thing. Okay? So if you're getting outside help, it might be that they're doing a different method. Okay? And you might find it's the easier method. Okay? If you find it's easier, no problem. I know how to mark it. Okay? I also have applied a different method, but I find this one to be easier for the learner to understand. Okay? But if somebody else explained to you, you will probably find a different method easier. Okay? Right, we're looking at example 1. Example 1 is on page 73. Okay. Example 1 on page 73. We have to consider the sequence 3, 6, 30, 24. Determine the general term, Dn of the sequence. So where do we start? We start by saying, not A, we write down the sequence. Okay. Okay, so I'm going to do B first. Is that okay? So B asks to give the next two terms in the sequence. People, that is normal. To ask you that first before they ask you what they did. Okay, so I'm going to do B first. Okay. So how do I move from term 1 to term 2? You're adding 3. Then 6 plus what is the 7. Then 11. So if it's 3, 7, 11. So I'm adding 4. So I must add 4 again. Then I must add 4 again. Not so. 11 plus 4 is 15. Add 4 again. 15 plus 4? 19. So what is 24 plus 15? 39. 39 plus 19? 15. And they have answered B. Calculate the value of the next two terms in C. People, is that difficult? So coming back to what I told you earlier on about those numbers here in yellow. You see those highlighted values here? I can't have now both screens, both shots in the same place. So let's look at A. So what do you think I'm going to write here on the side? What is 4A equal to? What is 4 equal to? What was on its place? 2A. Can you see that, people? Okay. Remember that the general term of the sequence is going to be Tn is equal to An squared plus Bn plus C. I had to actually start it. Okay? And why is it quadratic? Why is it a quadratic pattern? Because it has a second common difference, or second constant difference. Can you see that? So, what did we have on 4's place? 2A. So in other words, 2A is equal to 4. What did we have on this 3's place, on the first term of the first difference? 3A plus B. Can you see that? You see? What do we have on the first term's place? A plus B plus C. And they are right, A plus B plus C. On the bottom, we work. Okay. Why do we go from the bottom up? Because by 2A is simply equal to, what's 2A equal to? 4. Remember, I'm going to say 2A is equal to 4, 3A plus B is equal to 3, and A plus B plus C is equal to 3 as well. It won't always be the same value. It change. Okay. So let's go. 2A is equal to 4. So I divide by 2 both sides. So A is equal to 2. You guys understand? So now if you put A in here now, what would it now be? 3 times 2 plus B is equal to 3. So B is equal to 3 minus 6, which is negative 3. You guys understand? Simple, no? The last one, A plus B plus C is equal to 3. So what do we have? 2 plus negative 3 plus C is equal to 3. So C is equal to 3 minus 2 is 1, and 1 plus 3 is? Okay, so what's my general term? Therefore, Tn is equal to 2n squared minus 3n plus 1. Now that sum is normally worth 4 marks. Okay? It will be worth it testing it if it's correct. If I was not correct, I can just try and locate where my problem is. And how do I test? You don't have to write this down. Eh? I just use any value for n other than 1. Why don't I use 1? Because the first term was used to calculate C. So even though it could be wrong, your general term could be wrong. If I test it on the first term, it will be right. Okay, it will show the right answer. Why? Because I've used the first term in pursuit of calculating C. That is why it will be right. Okay. So I'm going to test any other number other than 1. I normally go with 3, term 3 or 4. So I'll go with 3 today. So wherever I see an I put a 3. Once I substitute 3 in here for term 3, what should I get an answer of? 13. So that is term 3. What if I had to substitute 4 when I see n? Then what should the answer then have been? 24. If it's correct. If it gives me any other value other than that, it is then incorrect. You guys understand? So we go with the calculator. Wherever we see an n, we put a 3. So it's going to be 2 times 3 squared minus 3 times 3 plus 4. Give me an answer of 13, which makes it correct. Or if I had gone with term 4, wherever you see n, you put a 4, it must give me an answer of 24, which is correct. People, you guys understand? What if the question says, what is the value of the 100th term? Then what do? Wherever I see n, I put a 100. So the value of a 100th term, or if you extend that pattern starting from 3 to 100 terms, you should get an answer of 90,704. You guys understand? Okay. You guys need to write this down, or can I carry on? Huh? Carry on. Okay. So let's look at the next example. So this one we'll do together. This example 2. And example 2 is on page 74. Alright. So what did we say? We're going to answer B first, okay? So write the sequence down. It's 4, 14, 30, 52. You write down the next 2 terms for me. Okay, so what are the so how do I move from one term to the next? I added 10, then 16, then 22, then 28, then 34. So I'm actually adding 6, not so. So 52 plus 28 is 70 is 80. Is that correct? Okay. And 80 plus 34 is going to be 1, 1, 4. I'm getting 1, 1, 4. Is that correct?
Yes, sir.
You all got that. Now I need you guys to write on the side here what variables go there and perform the equation. We're now doing B, nah? Sorry, A. So A was to determine the general term. It is in the form of Tn is equal to A squared plus Bn plus C. Alright, so what do I write on the side? 2a, then 3a plus b, then a plus b plus c. Move from the bottom up. Okay? So where do I start? I start by saying 2a is equal to solve for a. We're saying that 2a is equal to 6, so a is equal to 3. So what do I do with that a? I substitute it into a of the next equation. Not so. So what is it now going to read? 3 times 3 plus b is equal to 10. 3 times 3 is 9. So b works out to be 1. Okay. The next one. That a plus b plus c is equal to 4. So it will be 3 plus 1 plus c is equal to 4. So c is equal to 0. So what's my formula now? General term. Tn is equal to 3n squared plus 1n or n, the same thing. Now what do I do now? No, nothing. No. Test. Test if it's correct. Okay. So let's choose a number for n. The nth term, let's choose 4, the fourth term. So it's going to be 3 times 4 squared plus 4. Now the fourth term here is 1, 2, 3, 4. The fourth term is 52. If it gives me 52, I'm correct. There we go. Do you guys understand? That's how we do it. Okay. A common question that's also asked is which term. Okay, if they ask you what's the value of the 60th term, work out the value of the 60th term. What's the value of the 60th term? How do I do that? I just put in the calculator wherever I see n, I put the 60 plus n, which is 60. So the value of the 60th term is 10,860. Not so. Now, another common asked question is which term of the sequence, and this question was not asked. Put it here in purple. Determine, you guys can write this down. Determine the value of n if the nth term or Tn is equal to 27,170. Or they can ask you which term in the sequence above will have a value of 27,170. Okay.
Syukuran G.
Afwan kita. Okay. So that means to say if I extend this pattern, I extend it, there will be some term in the pattern which is equal to 27,170. You guys understand? Now they want to know which number exactly, which position number would that number lie. So you guys understand what they're asking? Okay. It's not asked in these examples, that's why I'm doing it now. Okay. So That is the nth term. Okay? And what is Tn? Tn is 3n squared plus n is equal to 27,170. So what must I do now? Yes, well done. Solve for n. So it's 3n squared plus n minus 27,170. Now, are we going to find factors here? No, there's nothing wrong with us yet. Not so. So what we're going to do, we're going to use the quadratic formula. In this case, it's now going to be n is equal to minus b plus minus the square root of b squared minus 4. A is 3, c is negative 27,170 over 2a, which is 3. So n can be one of two values, so we put that in the calculator. I hope it shows the right value there. That works. So it's negative 1 plus the square root. Oops. What's going on now? Negative 1 plus the square root of 1 squared, which is 1, minus 4 times a times c, 27,170 over 2a. It's going to give you 95. The first answer. And what do? I change that to a minus, gives you negative 283, I think it was, over 7. 286 over 3. 286. People know, what do we know? What is the nature of n? N is an element of natural numbers only. Not so? So what does natural numbers entail? It's 1, 2, 3, 4, all the way to infinity. Those are natural numbers. It can't be a fraction. Okay? And it can't be a negative number. Not so? So can it be negative 286 over 3? No. Can it even be a fraction? No, because we don't have a position 286 over 3. Okay? We don't have somebody coming at 2.5. You get person coming in first and second, and you got person that's coming in 2.5. No, we don't have that. You understand? So n denotes a position number, so n has to be a natural number. So I just omit that. Can you see that, people? That's to say, it can't be there. So I can end up by saying, therefore, the 95th term in the pattern is equal to 27,107. Okay, you guys understand? Any confusion? So with that, you should be able to do exercise 3.3. You do for me the first column. Okay. That is for tomorrow. Right.